Hi there! In this video we will cover all the projects you can create with our basic embedded kit. Our basic embedded kit consists of our starter development board called Clicker 2 for STM32 and two of our click boards. One of them is Temp and Hum 4, another one is USB UART click. We will show you how to write your own LED blink example, how to send Hello World string to a PC using UART protocol, and finally we will show you how to write an embedded application that reads the temperature and humidity values from the sensor and sends it to a PC using USB UART click. All code for this project we will write in our latest development environment, which is called NectoStudio. So let's start coding. For the LED blink example, we will use only the Clicker 2 for STM32 development board. This one is pretty easy. We'll write a simple code in NectoStudio which will allow us to blink these two LEDs simultaneously every second. First, we start with naming the project and selecting the project folder. In project template, we choose MicroC and MicroSDK application. Next, we will choose the Fusion for ARM hardware profile. And in the next window we'll see all the project details for the project we'll create. We will uncomment the driver digital out header file and uncomment digital out t context structure object and create additional object called LED pin 2. In application init section of the code, we will initialize driver objects LED pin 1 and the LED pin 2 with digital out init command. We will open the Clicker 2 for STM32 manual, and in the schematics below we'll find to which pins are LED 1 and LED 2 connected. We will change the names from LED 1 and LED 2 to appropriate pin. Finally, in the application task, we'll use digital out toggle command to toggle the LED pins, and we will add a small delay in between. Now we need to load correct clock settings, and we will do that by clicking on Edit Project icon, choosing MCU settings and double click on 168 MHz internal clock option. Now the only thing that is left is to build the project and use HID bootloader to program the code. For a Hello World example, we will use Clicker2 for STM32 development board and USB UART clipboard. We will write a code in a NectoStudio which will allow us to send a Hello World string from a development board to a PC terminal. We need to create a new project, set its name to Hello World, and choose Micro-C programming language and MicroSDK application. First thing we need to do is to include the UART driver header file. We can access the content of that file by left click on the file name and choosing Go to Definition. There we can read the detailed description of the commands used in the file. We need to create a UART object and two variables, one for UART receive and another one for UART transmit buffer. We'll also create two additional variables which will be used later in the code. In application init section, we need to define UART pins. We'll start by creating UART pins context structure object and assigning the pin names. Once again, we'll find the pin information in Clicker2 manual. As the USB UART click is connected to Microbus 1 socket, the pins used are PD6 and PD5. After assigning the pins, now we need to call UART open command. We can also use Ctrl plus space on keyboard to access the code assistant. We can also get additional information about the command by pressing the F2. Now we need to set the UART baud rate to 56,000. Now we need to use UART print line to send the hello world string to a terminal. We could finish here, but let's use those two variables we declared at the beginning of the segment, size and buffer, to check if there's any string sent from the terminal and echo it back. We'll use two additional commands, UART read and UART write. Now, as in previous example, we need to load the appropriate 168 MHz internal clock settings, build and program the code with HID bootloader. Then we need to open your terminal, connect to appropriate COM port, and wait for a hello world string to appear. We can test additional functionality of the code by typing any string or number in sandbox. Finally, in this segment we will combine what we learned so far and add some additional functionality to the project. So let's write a code that will read the temperature and humidity data from the sensor and display it in PC terminal. Worth mentioning is that you can manage, create or edit different hardware profiles, choosing between different SDK, boards, MCU or debugger options. As Clicker 2 is not yet added in the NectoStudio, but will be in the future updates, we need to change some of the pins. I've included modified board header file from which you can copy the pins used. We will work with temp and hum for clipboard. For that we need to open a package manager and install the library. After installing the library, a demo example will appear in the example section. We could open that example, do some change to the UART pins, and that would be it. But let me show you how you could import library into a project and write a project from scratch. We include the library by right-click on the dependencies in the project manager window and selecting appropriate library. For this example, we will include temp and hum 4 and log library. First lines of the code would be adding includes of temp hum and log headers. In application init section, we need to configure both log and temp hum objects. USB UART click is inserted in Microbus 2 socket. It uses D9 and D8 pins. Temp and hum 4 is inserted in Microbus 1 socket. We will map it in configuration, initialize it, and load default config values. In application task, we will create two float variables, temperature and humidity. Then we'll use getTemp and getHumidity to obtain values from sensor. We will use logprintf to send that data to the terminal. We can place the finger on the temperature and humidity sensor and watch in the terminal how the temperature rises. Thank you for watching. All the files and project resources are available from the links in the description below. Till next time.